In this episode, we're going to treat detection as something you build into a system from the beginning, not something you bolt on after an incident scares you. Beginners often imagine security as mostly prevention, like keeping attackers out. But real security also depends on noticing when prevention fails or when something unexpected is happening. Detection is the part of security that tells you what is going on, what changed, and what deserves attention right now. Without detection, you may still have strong controls, but you will not know whether they are working or whether someone has found a way around them. Detection by design means you plan for evidence, what you will log, where you will store it, how you will watch it, how you will alert on it, and where you will place sensors so you can see the right traffic and behavior. The goal is not to drown in data. The goal is to create visibility that is reliable, useful, and tied to action. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Central logging is the foundation of detection because logs are the record of what systems and users did. If logs are scattered across devices and kept only locally, you lose them when a system crashes, you miss correlations across systems, and attackers may be able to erase evidence more easily. Central logging means collecting logs from many sources into a single place where they can be searched, analyzed, and protected. This is valuable because attacks rarely stay within one system. An attacker might log in, probe for access, move laterally, and access data across multiple services. If you can see those events together, you can connect dots that are invisible in isolated logs. Central logging also supports investigations after the fact because you can reconstruct timelines and understand scope. For beginners, the key is to see central logging as a design requirement, like having brakes on a car. You do not add brakes after the first accident. You design them in because you know accidents happen. The next question is what to log, because logging everything is not realistic and can create its own problems. Logs consume storage, can slow systems, and can accidentally capture sensitive data if you are careless. Detection by design focuses on logging that supports security questions, such as who accessed what, from where, and whether the access was allowed. Identity events are especially important because many attacks revolve around credentials, so authentication successes, failures, and changes to accounts are high value. Authorization events matter too, such as access denied events or changes to roles and permissions. System events matter, such as service starts, configuration changes, and unexpected errors. Data access events matter, especially when sensitive data is involved, but they must be designed carefully to avoid logging the data itself. The mindset is to log decisions and actions, not secrets, and to capture enough context that an alert can be investigated without guessing wildly. Log quality matters as much as log quantity, because low-quality logs create noise rather than clarity. A useful log event has a consistent timestamp, a clear event type, the identity involved, the target involved, and the outcome. It also has enough context to help you tell normal from abnormal, such as the source location, device, or application component. If logs are inconsistent across systems, investigations become slow and error-prone because you waste time translating formats and aligning timelines. Detection by design, therefore, includes normalization, which means making logs consistent enough to compare. It also includes time synchronization, because a few minutes of clock drift can make an incident timeline look impossible. Beginners should understand that attackers exploit confusion, and messy logs create confusion. Clean, consistent logs reduce confusion and increase the speed and accuracy of response, which is the real reason logging is a security control. Monitoring is the practice of watching signals over time to understand what is happening now and what is normal. Logs are the raw facts, and monitoring turns those facts into awareness. Monitoring includes dashboards, queries, metrics, and patterns that show the health and security posture of systems. A beginner mistake is to treat monitoring as a screen someone watches all day, but effective monitoring is more about building the right views and checks so problems stand out. Monitoring can include baseline behavior, like typical login volumes, typical data access patterns, and typical network flows between systems. When behavior deviates from the baseline, it may indicate an attack, a misconfiguration, or a system failure. The point is not to assume every anomaly is an attacker, but to recognize that anomalies are the entry point for investigation. Monitoring by design means choosing signals that help you detect both malicious activity and operational issues, because attackers often cause operational symptoms like latency spikes, error rates, or unusual resource usage. Alerting is the part that interrupts a human, so it must be used carefully. If you alert on everything, people will start ignoring alerts, which is called alert fatigue, and then even serious alerts will be missed. Detection by design means you define what conditions truly require attention and you tune alerts so they are actionable. Actionable means the alert includes enough information to start triage, and the alert represents something that is likely to matter. A simple example is repeated failed logins followed by a successful login from an unusual location, which could suggest credential stuffing or account takeover. Another example is a sudden change in permissions, especially when it grants administrative access. Another example is a server making an unexpected outbound connection to the internet, especially if that server normally communicates only internally. These are patterns that represent meaningful risk, and they can be expressed as alerts that prompt investigation rather than panic. An important idea for beginners is that alerts should be mapped to likely threats and to response steps. If you cannot imagine what you would do after receiving an alert, it is probably not a good alert. Some alerts are informational and belong on dashboards rather than in paging systems. Others are urgent and should trigger immediate action, like disabling an account, isolating a system, or escalating to incident response. Detection by design includes defining severity levels and routing alerts appropriately, so a minor issue does not wake people up at night, while a major issue is treated casually. It also includes suppression and grouping, so one underlying event does not create hundreds of duplicate alerts. The goal is to preserve trust in alerting, because trust is what makes people respond quickly. When alerting is reliable, responders act with confidence instead of skepticism, and that speeds up containment. Sensor placement is where detection becomes architectural, because where you observe determines what you can detect. Sensors can be network sensors that watch traffic, host sensors that watch system behavior, application logs that report business events, and identity logs that record access decisions. If you place sensors only at the perimeter, you may see scanning and external attacks, but you may miss lateral movement inside the environment. If you place sensors only inside, you may miss the early warning signs at the boundary. Detection by design means placing sensors at key choke points, such as boundaries between trust zones, entry points for remote access, and paths to sensitive systems. It also means placing sensors where high-value actions occur, like administrative changes, data exports, and authentication flows. The aim is not to watch everything, but to watch the places where attacker movement must pass or where the impact of compromise is greatest. A beginner-friendly way to reason about sensor placement is to think about what you would need to know during an incident. If an account is suspected of compromise, you want to know where it logged in, what it accessed, and what it changed. That means you need identity logs, access logs, and change logs. If a server is suspected of compromise, you want to know what processes ran, what network connections it made, and whether it touched sensitive data. That means you need host telemetry and network visibility. If a web application is under attack, you want to see the request patterns, error rates, and unusual payloads. That means you need application logs and possibly specialized inspection at the web layer. By asking these questions early, you can place sensors where they will provide those answers. Detection by design is essentially designing your future investigation experience so it is possible to respond without guessing. Central logging and sensor placement also have a security requirement that many beginners overlook. Logs must be protected. If attackers can modify or delete logs, detection becomes unreliable and investigations become frustrating or impossible. Protecting logs means controlling who can access them, ensuring they are stored with integrity protections, and limiting who can delete or alter them. It also means considering the risk of sensitive data appearing in logs, because logs are often widely accessible to operational teams. So you want to minimize sensitive content in logs while still capturing the evidence you need. This is a trade-off, and detection by design handles it by logging identifiers and events rather than raw sensitive data. When you do need more detailed logging for troubleshooting, you can restrict it and limit its retention. The central idea is that logs are security assets, so they must be treated like other sensitive assets, with access control, monitoring, and retention policies. Retention is another design choice that affects detection because you need logs long enough to discover slow attacks and to support investigations. Some attackers move quickly, but others move slowly to avoid detection. If you keep logs for only a short time, you may discover an intrusion after the evidence is gone. On the other hand, keeping logs forever may be costly and may increase the privacy and compliance burden. Detection by design means choosing retention periods based on risk, regulatory requirements, and practical storage costs. It also means ensuring that logs remain searchable and usable over that retention period. A log archive that cannot be queried efficiently is like a library where the books are stacked randomly without labels. The goal is to balance cost, privacy, and investigative value in a way that supports real response needs. Monitoring and alerting also need continuous tuning because environments change and attackers adapt. A pattern that was abnormal last month might become normal after a new feature is released. A threshold that worked during low usage might flood alerts during peak usage. A detection rule that catches one attacker technique might miss a variation. Detection by design, therefore, includes a feedback loop. You review alerts, improve rules, suppress noise, and add new signals when you discover blind spots. This is not busy work. It is how detection stays reliable. Beginners should understand that detection is not a one-time setup. It is a living part of security operations that evolves with the system. When you treat detection as a design discipline, you also treat it as an ongoing maintenance discipline. The more consistent that maintenance is, the more trust you can place in your monitoring and alerts when something truly unusual happens. The strongest detection programs also connect technical signals to business meaning, because business context is what helps you prioritize. A login anomaly on a test account might be interesting, but a login anomaly on an administrator account might be urgent. A burst of failed logins might be noise, but a burst targeting high-value users might signal a targeted attack. A data access spike on public data is less urgent than a data access spike on regulated data. Detection by design includes tagging assets and identities so monitoring can incorporate importance. This is where classification and architecture meet detection, because you can't prioritize what you haven't identified. The more your detection understands what is critical, the more it can focus attention where it matters. That focus reduces fatigue and increases speed of response, which is what turns detection into real risk reduction. To bring it all together, enabling detection by design means building a system that produces trustworthy evidence and making sure that evidence is visible and actionable. Central logging collects the facts in one protected place where correlations and investigations are possible. Monitoring turns those facts into awareness by tracking baselines and highlighting anomalies. Alerting turns awareness into action, but only when tuned to be meaningful and reliable. Sensor placement ensures you can see what matters at the boundaries, in the pathways, and around high-impact actions, so attackers have fewer places to hide. When these pieces are designed intentionally, detection becomes a strength of the architecture rather than a desperate reaction to surprise. For SecurityX learners, the key habit is to design systems so you can answer incident questions quickly and confidently, because the faster you can see what is happening, the faster you can contain it, and the less damage attackers can do.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.